Miniature human brains with their own blood vessels had been grown in a lab for the first time. After implanting the mini brain, which only a millimeter long, into a mouse for 2 weeks, they found it had grown capillaries that penetrated all the way to its inner layers. The achievement could help researchers to grow bigger brains in the life in an effort to better study how the organ works. In the future, researchers hope to use the artificial brain tissue to cure stroke victims. Scientists at the University of California at Davis are behind the latest findings. The study was inspired by research from Dr. Ben Waldu, a vascular neurosurgeon at UC Davis, that focused on a rare condition called Moyer-Moyer disease. Patients had blocked arteries at the base of their brain, keeping blood from reaching the rest of the organ. To study the brain, often scientists use lab-grown cultures of stem cells. Although these traditional cultures are useful, they are also very limited in aiding our understanding of complex structures in organs. The least understood of all human organs is the brain, and the miniature lab versions afford researchers unprecedented insights into how different regions of the brain work together. The whole idea with these organoids is to one day be able to develop a brain structure the patient has lost made with the patient's own cells, says Dr. Walda. We see the injury still there on the CT scans, but there's nothing we can do. So many of them are left behind with permanent neural deficits, paralysis, numbness, weakness, even after surgery and physical therapy. We sometimes lay a patient's own artery on top of the brain to get the blood vessels to start growing in, says Walda. When we replicated that process on a miniaturized scale, we saw these vessels self-assemble. This budding field of growing human organs has expanded rapidly, starting with groups of immature stem cells, to more complex arrangements. As the field develops, so do the organs themselves, and a major stumbling block has been replicating the blood flow throughout the complex organ. At a certain point in size, the organoid becomes too large and it dies at the center. To overcome this, Dr. Waldo and his colleagues combined stem cells with other human body cells to encourage the formation of blood vessels. By using endothelial cells and stem cells from the same patient who was undergoing a routine operation, it ensured there would be no rejection. As the stem cells grew into a small ball, it was incubated in a specialist gel and was already coated with the endothelial cells. After a short period of incubation and growth, it was transferred from the gel to the brain of a mouse. Researchers carved out a small cavity in the brain of a mouse and the organoid was then implanted here. The mouse, still alive despite the brain operation, then played host to the tiny human brain for 2 further weeks. After this in vitro period was completed, the small brain had become successfully infiltrated by blood vessels. It had even created its own capillaries, which extended throughout the brain and all the way to the center. This discovery will allow future research to be conducted on bigger organoids and therefore understand more about higher functions of the human brain. It's a big deal, said Christoph Koch, president of the Allen Institute for Brain Science in Seattle, but it's still early days. The next problem will be getting these cells wired into circuits that can receive and process information. The fact that I can look out at the world and see it as spatially organized, left, right, near, far, is all due to the organization of my cortex that reflects the regularity of the world, says Koch. There's nothing like that in these organoids yet.